Hello students, in this video we'll solve a couple of problems from exercise 7.2 under the triangles chapter. The first problem of this video is in triangle ABC, AD is perpendicular bisector of BC. We have to show that triangle ABC is an isosceles triangle in which AB is equal to AC. If we need to show that AB is equal to AC, we will have to prove these two triangles congruent to each other. Remember, we need to show this side is equal to this side. And if we prove that these two sides are equal, we can say that this is an isosceles triangle because these are opposite sides. And when opposite sides of a triangle are equal to each other, we can say that it is an isosceles triangle. So let us first begin by trying to prove these two triangles congruent to each other. That is, let us put down the triangles. We will say in triangle ADB and triangle ADC. What do we see? We see that the side AD is common to both of them. So we write AD is equal to AD, which is a common side. We can see that this has AD is a perpendicular bisector of BC, which means that AD forms angle ADC and angle ADB are 90 degrees both. So we say angle ADB is equal to angle ADC, and both of them are equal because they are 90 degrees, because we have been given AD is perpendicular to BC. Next, we have been given that this is a perpendicular bisector. Bisector meaning AD divides BC into equal parts. Which are those equal parts? BD and DC, which means we can say that BD is equal to DC. Okay. Why? Because AD is perpendicular, or we just say AD bisects BC, and this has been given to us. So now we have got side, angle, side. So this side, angle and side. So we can say therefore triangle or triangles ADB or triangle ADB is congruent to triangle ADC by SAS congruence criterion. Fine. And now that we have proved these two triangles as congruent to each other, we can easily say that AB is equal to AC by CPCT. And in showing that AB is equal to AC, we can easily conclude that triangle ABC is an isosceles triangle. Okay, because opposites, or you can say since opposite sides of triangle ABC are equal to each other. Let's solve another problem. Our next problem says ABC is an isosceles triangle in which the altitudes, these are the altitudes or the heights, BE and CF are drawn to sides AC and AB respectively. Show that the altitudes are equal, which means we need to show BE is equal to CF. To show that, we'll have to prove a couple of triangles as congruent to each other. If we do that, which are the triangles? What I'll do is I'll just keep the triangles from this figure. I'll just keep the triangles that we need to prove congruent. That will make it easier for you to see what are we dealing with. So I'll just draw them. Okay, this is your A, this is your F, this is your E, this is your C, and this is your B, and this is perpendicular. Okay, we have drawn the same diagram except I've omitted or excluded BC to make it easier for you to see what we are dealing with. What we'll do is write solutions and we'll take the triangles that we need to prove congruent. We'll take AEB and triangle AFC. Okay, these two triangles we need to prove congruent. Now we have been given this triangle ABC is an isosceles triangle, which means AB should be equal to AC. Okay, we'll just assume that. So AB equal to AC, since triangle ABC is an isosceles triangle. Okay, so AB belongs to this triangle AEB and AC belongs to triangle AFC. Nice. So we have got that one. We can also see that these two triangles, that is triangle AEB and AFC, share one common angle, that is A. So we can write this as angle EAB is equal to angle FAC, say common angle, right? So we've got an angle, we have got a side. Now can we find something else over here? Have a look at the diagram. We have been given that BE and CF are altitudes. Altitudes means they form right angles with their bases, their heights, which means we can say here that these two angles are 90 degrees. That is, which are the angles? In case of triangle AEB, it will be angle AEB. Angle AEB is equal to angle, this is in case of triangle AEB. In case of triangle AFC, it is angle AFC, and both are equal to 90 degrees, because we have been given that BE and CF are perpendiculars. Okay, now we have got angle, angle and a side. So have a look where they are. We have got an angle, this one, mark them in blue, angle, angle, and there is a side, that is this one. So by AAS we can say that the two triangles are congruent to each other. We say therefore triangle AEB is congruent to triangle AFC by AAS congruence rule. And now that we have proved that these two triangles are congruent to each other, we put our focus back on what we are asked to show, that is the altitudes are equal to each other. Which are the altitudes? BE and CF, and they are corresponding parts of congruent triangle. So we can say BE is equal to CF, or you say therefore by CP CT. Okay, this implies that altitudes are equal. Hence the proof. If you've liked the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and click on the bell icon to be notified whenever a new video is posted. Thanks for watching. See you in the next video.